Hey kids, I'm back. Okay, lesson 22. Now, this one is, the objective is to divide 3 and 4 digit dividends. So we're getting some pretty big numbers inside the bracket by 2-digit divisors resulting in 2 and 3 digit quotients. So we're going to be talking more about what's happening up on top of the bracket with the quotient and reasoning about the what's called decomposition of successive remainders in each place value. So how can I break up what's left down here so that I can regroup it and figure out how to put my numbers appropriately in the quotient. So this is just a practice problem your teachers might go over with you before you start lesson 22. And so again, you're going to round the divisor first. That's just going to help us figure out what type of digit we would put in the quotient and where we would put it. And again, we're going to talk a lot about renaming these numbers. This would be 3 in the tens, so 3 tens times 17. It's not giving us 51. It's really 510 when we get into these larger problems, but that's okay. This is always going to be a 0. It just doesn't affect anything as you go down. So we'll show you on some of the problems when we get into the book. And so round the divisor first, round this to something that's compatible, something close and easy. Eliminate any extra zeros, and then 6 divided by 2 would be 3. And why do we do all this? It's really just to figure out what to put in the quotient for our first digit or the second or subsequent numbers that we're guessing. And again, just like in lesson 21, it is okay if you have to erase and start over, and you'll have to do that a lot. So get used to it. It's not a problem. So let's jump right in. It's kind of a lot of thinking and talking through some of these problems. So here we are, lesson 22. We're going to divide, then check using multiplication, still using our check strategy, and the first one is done for you. So we'll hop right into part B. So 32 is the divisor, and 730 is your dividend. And so it's really important to just kind of, I wish I had 30 so that I could count by 3. Well, I can still do that. If I had 30 and I went 30, 60, 90, I would see that I can really just start with a 2 here. Let's section that off so we don't mix it up. Now, why do I want to put this in the tens place instead of over here or over here? Because when I multiply, let's just say 30 times 20, the only way I can get the right amount to subtract is if I put the 2 in the tens place. If I put the 2 over here in the ones place and I have 32 times 2, I'm going to get 64. That's 64 ones, but I'm not doing that. I need to be over here in the hundreds place and the tens place. That's why this has to go here. So 2 times 2 is 4, and 2 times 3 is 6. And so really it's 20 times 32, which is really 640. But let's just leave that as 0 for now, or nothing, and find the difference between 64 and 73. And so if that was 74, the difference would be 10, but it's 1 less, so the difference is 9. You can always use the standard algorithm, though. Take 1, give 10, and do the subtraction that way. So I'm left with 9 here, and that is less than 32, and then I can bring down my 0, and so I'm regrouping. This is really 9 tens that are left. And so 9 tens have the value of 90 once I have brought down my 0. So if I had 30, then I would say 30, 60, 90. How pleasant that would be. But I don't have 30. I have 32. So this is only to help us estimate, but we are no longer using actual 30. We're actually dividing with 32. So I can't have 3 here. I need to have it 2, because if I use 3, I'm going to go over 90. So 2 times 2 is 4, and 2 times 3 is 6. And now we find the difference between 90 and 64. You can use the standard algorithm if you like to do that here, so we'll do that one for this subtraction. Take 1, give 10, 0 plus 10 is 10, 10 minus 4 is 6, and then 8 minus 6 is 2. So you have a remainder of 26. And then, of course, you're going to do your check over here. And so you have your outer 2. Now, this is going to be where you have a little bit bigger multiplication problem. Okay, so now we have double digits. So in the lessons previous, it was a 2 times a 1, but we have larger divisors now. Okay, so 2 times 2 is 4, 2 times 3 is 6. And then hold this spot with the 0, move over to your tens place. 2 times 2 is 4, 2 times 3 is 6 again. Add those up, and you get 704. But we can't stop here because we also have a remainder. Okay, so we're going to take that 704. I'm going to move it up because I don't want to creep into the space for the next problem. And we're going to add, thank you. We're going to add our remainder on. So 6 plus 4 is 10, carry the 1, 2 plus 1 is 3, and then we have 730. Now this is what finally gets to compare to what we started with for our dividend. Okay, so the 730 is what we shared evenly and put into 32 groups with 22 in each one with a remainder of 26. So that's what is happening with all these bigger numbers. So it's the same strategies, just it takes a little bit more time to work it through. Okay, so let's do the next one. I don't want to run out of room, so I'll move it up now. There we go. All right, so here's our 28 divisor and 940 dividend. Now if I had 30, it'd be real easy to count by 3s to get to 9. So I'm just going to guess if I had 30, since this is lower than 30, I can get to 90 with 3 of them, and I'll be okay. I won't go over like we did last time. So 3 times 8 is 24, and then 3 times 2 is 6 plus 2 is 8. And subtract, and you get 10 left over. Now, again, this is 3 tens, and so it's really 3 tens that are multiplied by 28 that give us 840. But we're, with the standard algorithm, we're just using these numbers here. Now we're going to bring down, because 10 is less than 28, bring down the 0 and divide again. Now if I had 30, I already had done 3. I know that 3 times 28 is 84. And I need to get up to 100, but without going over it. If I was to have another group of 28 added onto this, I would go over 100. So I'm just going to use 3 again. And I'm going to use my number that I already multiplied. I did this already. 3 times 28 is 84. So I'm going to do that again and put 84, because I already did that, and find the difference. And of course, it's the same difference again, okay? So, oh, sorry, my bad. Boop. We're not subtracting from 94, we're subtracting from 100. So it's not going to be the same, but every now and then you'll get numbers that start to repeat. I think I'm thinking ahead, but you'll get numbers that start to repeat, and you'll do the same thing. Once you get 2 of those, you just put a line, but we don't have that yet, so I'll tell you about that in a little bit. So do your standard algorithm subtraction, or just find the difference. You can recognize that the difference between 84 and 100 is 16, or you could do the standard algorithm either way. But if I had 85 and I went to 95 and then 100, that's 15, but it's 1 less than that. So I'm just going to leave that at 16 and call the remainder 16. So take your quotient and divisor and set up your check. And this is the fun and easy part. 8 times 3 is 24, 24, 25, 26. Hold this spot with a 0, done with the 1s. Move to the 2 tens. 2 times 3 is 6, 2 times 3 is 6. Nothing else to multiply. Add these together. 6 plus 6 is 12. Carry the 1, 6, 7, 8, 9. Now we have 924, but I also have 16 as a remainder. Since I have a little bit more room here, we're going to keep it all in a row. And 6 plus 4 is 10. 2, 3, 4. 940, and go up and show that you got the answer you started with. And huzzah, time for a celebration. Next one, 23 is our divisor. 553, it's kind of a long bracket, but that's okay. So 23, if I had 25 like a quarter, and I had 2 quarters, I would have 50 cents. I know I can have at least 2 23s, and I will have plenty. I'll have some leftovers, but that's okay. So 2 is my guess. And again, it's 2 in the tens place because when I multiply, I'm going to have, my answer is in tens. So 2 times 3 is 6, and 2 times 2 is 4. So 46 tens is really 460. Don't tell anybody. And then you need the difference between 46 and 55. Now, if I was finding the difference between 46 and 56, that would be 10. But it's less than that. It's only 1 less than that. So that is 9. You can do the standard algorithm if you want and take 1 and give 10 and do 15 minus 6 and get 9. You'll get it either way. Then the compare step. Compare this. It's less than 23, so we can move on. Bring down your 3. Divide 93 by 23. So if I had 20 and I did 20, 40, 60, 80, I would see that that's 4. But if I did 5, I would have 100, and that's too big. So I can try the 4 and consider that I still am going to have extras because I'm not using 20. But 4 times 3 is 12, carry the 1, and then 4 times 2 is 8, plus 1 is 9. And it worked out okay, and I only have a remainder of 1. Okay, so take your 24 and multiply it by your divisor, 23, and start solving. 4 times 3 is 12, 3 times 2 is 6, plus 1 is 7. Hold the spot for the 0, done with the 1s. 4 times 2 is 8, 2 times 2 is 4, and that gets us 15, 552 plus 1, 553. And huzzah! That's what we started with. So that's what our goal is every time, is to check and make sure we're calculating correctly, that we subtracted correctly. I mean, I make mistakes all the time. I'm sure you guys make some mistakes every now and then, probably not as often as I do. But it's a good way of checking yourself. So on the back side, we have 2 more problems, and this time we have a 0. So 46, and our dividend is 704. Now, when you have a 0, you still have to count this place value position, okay? So I potentially have 3 digits I could put up on top. First of all, I'm going to have a 0 here, so I'm not going to put anything because 7 is not divisible by 46. But it is 70 is divisible by 46. Now this is a pretty big divisor, and this is not that big. It's almost 50, and this is nowhere near 100. So I'm going to put 1 up here for my first partial quotient, and then multiply and get 46. Now I need to find the difference, and I'll use the standard algorithm. Take 1, give 10. 10 minus 6 is 4, and 6 minus 4 is 2. Compare. I should have less here in my remainder than I have here, because if I have a lot here, then I can make a full set, okay? Or if I have a lot here, I can make another full set of 46, but I just have a little bit. So I'm going to go forth and bring down my 4 that is 4 ones. Now I have a total of 244 ones being divided by 46 ones. So if I had 50 and I counted by 50, it'd be 50, 100, and then 150, 200, and then 250. So if I had 5 50s, I would be around 250. Well, I'm really close to that, but I don't even have 50. So I'm going to go ahead and try a 5, and hopefully it will work. 5 times 6 is 30, and 5 times 4 is 20, plus 3 is 23. And then 4 subtract a 0 and get 4. 4 minus 3 is 1, and I have a nice small remainder, and I have nothing else to do here except put it up in the remainder. So I'm going to take my 46 times 15, and sometimes you may have noticed that I'll put the quotient on the top, and sometimes I'll put the divisor on the top. It doesn't matter because of that commutative property of multiplication. You can change the order however you want, and you'll get the same answer. Whatever you get to this, you're going to add the 14 to. If you have your numbers switched, 15 on top and 46 on the bottom, you won't have the same partial products as me, but hopefully you'll get the same final product, and then you can just add 14 to yours. 5 times 6 is 30. And then 5 times 4 is 20, plus 3 is 23. Hold this spot with the 0 because I'm done with the 1s and move to the tens place. 1 times 6 is 6 and 1 times 4 is 4 because 10 times 46 is 460. So that should still make sense to you. And then add. And I have 690, but I must add my remainder. This comes down, and we end up with 704, which is what we started with. Huzzah! Okay, last one, and we don't have a 0. Not that they made that last one too hard. So we have 614 divided by 15, and make sure when you read it to your teachers or participate in class, you're going to say this is being divided by that. Don't start on the outside. Say it with this is being divided by this. So 61. Now I can count by 15s. If you get a little bit of practice, 15 plus 15 is 30. 30 plus 15 is 45, and 45 plus 15 is 60. So I know that 4 15s make 60. After a while, you just start to know these things. If you don't, just go ahead and make your guess up on top and then adjust to find the Goldilocks number, the one that's just right. Do your subtraction, we get 1, and then we have 14 that are left over. So what do I do with 14? And when I can't divide by this, you still must have a digit in the ones place. You can't just stop here and put remainder 14. That is not the answer, okay? This has to have something. It's 4 10s and how many 1s? Even if you have a 0, you have to hold this place value position with the 0. Then you would multiply and get 0 and do the subtraction. Here is my remainder. Yeah, it's 14, but that's a far cry of a difference between 4 with a remainder of 14 and 40 sets of 15 with a remainder of 14. Okay, so big difference. And then because I love to put the zeros on the bottom, I'm going to do 15 times 40 with the 0 on the bottom, so I can go 0 times everything is 0. Now my ones place is done. 4 times 5 in the tens is 20. 4 times 1 is 4 plus 2 is 6, and I get 600. But I still have to add the remainder, and so I end up with 614, which is what I started with, which makes me say, huzzah! Okay, so those are all of the beginning problems. So now we have a real thinker. All right, Hallie solved 664 divided by 48 below. Okay, right here. She got a quotient of 13 with a remainder of 40. How could she use her work here to solve 659 divided by 48? Different dividend, same divisor, but without redoing the work. Can we do it? So let's think here. We have to think about this. This is not a show your work. Guess what? No work is going to be here. Words will be here. So think logically. This is our total that is the whole. It's what's being shared. Okay? And if I'm going to make 48 groups and have 13 in each group, what if I have less to share? but I have the same amount of groups. So what it comes down to is you look at this and you say, well, if 659 is being used, that's less. So write this, 659 is less. Now, how much less? Well, it's 5 less. Okay, so 64, the difference between 64 and 59, that's 5. It's 5 less than, THAN comparison, 664. So where does that difference come out? It's going to come out down here, minus 5. So the remainder would be 5 less. Okay, because I still have enough. I just have a huge remainder here. So we would start, everything would be typically the same, but the remainder is going to be less. Okay, but the quotient root would be the same. The remainder would be 5 less, but the quotient would be the same. Okay, now that is just, you're just trying to make full sets. So every time you start a new set, you have to count to 48 before you can get up to another one. So I would need more in here in my dividend in order to make another full set. Like I was only 8 away down here. I was only 8 away when I had 40 remaining. If I just had 8 more up here, I could have bumped this up to 14. So that's the thinking behind it. It's like, what do these numbers mean? This is the total that's being divided. These are the amount in each set, or 48. So I got to count to 48 13 times. Okay, and if I already got to 40, I would just need 8 more so that I could bump that up to 14. So that's what that's all about. You have to explain your thinking, not do a whole bunch of math. Okay? All right, let's try to wrap it up. Oop, yep, getting up past 20 minutes here. 27 students are learning to make balloon animals. Ooh, how fun. There are 172 balloons to be shared equally. Keywords among the students. How many balloons are left over? Ooh, there's our question, answer. After sharing them equally. So first we need to share them equally. So let's take our total first. 172 divided by 27. And always, try to round the divisor first so that you can get close to a good guess in your quotient. So if I was able to do this, then I would guess that maybe 6 would be my first digit in my quotient. Won't always work out, but it might be close. So if I give that a try, 6 times 7 is 42, and then 12, 6 times 2 is 12, 13, 14, 15, 16. I did get pretty close, and I have 10 left over. So 10 balloons, this is the question or the answer to the question. 10 balloons are left after sharing evenly. So the remainder, this is all balloons. This is all the balloons. These are the kids. And so how many would everybody get? 6, but there are 10 left over, and you don't have enough to share anymore. But part B, it says, well, if each student needs 7, they don't have them, how many more balloons are needed? So, okay, you have to stop and think. I know everybody gets so excited, like, I better divide. We're working on division in lesson 22. Not always. So let's think about this logically. Okay, if I have 172 to start, and I divide it by 27, and each kid's going to get 6, what do I need to find out? Okay, so I already have the information I need. I have 27 kids. There aren't any more kids. I just need more balloons. And so you look at this remainder. How can this help you? I already have 10 balloons, but I need more. how many more do I need so that I could get up and make that full set? That's the question that we just answered on 2. It's how do you use this? What does this represent? Well, this represents the whole pile that's being added or like set up for the next group. I'm on my way. I have 10, but I need more. So if I have 27 kids and I already have 10 balloons already, then I just need to, I hope you were thinking, find the difference to see how many more balloons I need. So if you do subtraction here, 17 more balloons are needed to make another full set. Another full set of 27, okay? So that each kid, I should say student, can have 7, okay? I hope that makes sense. So 17 more balloons are needed. This is the question. How many more? 17 more. This isn't going to change. I already have some. Don't go out and buy a package of 500. You only need 17 more. So that's today's lesson. Kind of a tough one and a long one, but I sure hope this has helped. If it was helpful, you can subscribe and you'll get notified when I have a new video that I've posted. Anyway, you guys take care. Thanks for all the sweet comments. You guys are so thoughtful.